everyone, today's video is going to cover on chapter 7.2 where the objective is to multiply and divide simple algebraic fractions. To do this, we need to recall how to simplify algebraic fractions, and that is covered in the previous video. If you have forgotten about it, you may want to check the previous lesson video. So we will first try to recall on the numerical fractions behaviors first, okay, because those are things that we are familiar with. So in the very first example that we will look at is when we want to multiply or divide by a fraction itself. So in this particular question, we have half times 3 over 5. Okay, so when we have half times 3 over 5, what we usually do is to just simply multiply the numerators and also multiply the denominators together. Okay, then after that we will simplify, alright, whenever it is possible. In this particular case, we will get the answer to be 3 over 10, which cannot be further simplified anymore. Alright, so with this set of skills, when we go into algebraic fractions, a over b times c over d, right, we just simply have to multiply the numerator and also multiply the denominator together. Then after that, if necessary, okay, if it is possible, we will then proceed with simplifying. Then what about if we were to be doing division? So just like what we have learned in primary school, okay, when we have division, right, okay, of a fraction, what we must do is to first flip the right fraction, okay, meaning to say the fraction on the right, okay, we flip it and then change the operation into a multiplication. Then the process will be the same as what we did just now, where we multiply the numerators and also multiply the denominators. In this particular case, we get 10 over 12, which can be simplified to get 5 over 6. Alright, so drawing this idea into our algebraic fraction, okay, when we want to divide two fractions together, two algebraic fractions together, we will first do a flip, okay, and then after that change to multiplication, then multiply numerator, multiply denominator. So earlier on, we were looking at multiplying or dividing by a fraction. So now what if I have a fraction and I want to multiply or divide by an integer? An example of an integer are things like your whole number or maybe negative whole number, so-called. Alright, so in this case, we have 2 over 3 times 5, alright, where we're multiplying by a times 5. We need to understand that the whole number 5, right, is the same as considering 5 over 1. Okay, so I can now see that it is actually a fraction times a fraction. So having an integer in place, right, doesn't quite make any difference. So we will just go through the same steps where we multiply the numerator and also multiply the denominator, and then we simplify our answer if possible. Alright, hence when we go into algebraic fraction, if I have a fraction and multiply by, let's say, c, okay, I only bring c up into the numerator, okay, because c is considered as c over 1. So I will get a times c in the numerator and b times 1 in the denominator. Therefore, my answer will be ac over b. So this is a very generic case. Now, what about if I were to divide by a whole number instead? So for example, 2 over 3, I divide it by 5. So same idea still continues. So 5, you must think of it as 5 over 1. So we will do the flipping of the fraction on the right, okay, such that I will get times 1 over 5. Then I multiply by the numerator and, multiply the numerators together and multiply the denominators together. Then I simplify if it is possible. So going into an algebraic case, I consider my letter c, okay, my variable c as c over 1, okay. Hence, I will get a times 1 over c when I flip the fraction. Alright, and then I multiply numerator, multiply denominator. Therefore, my answer will be a over bc. We will now take a look at example 4a, where we would like to simplify this question. So in this question, what we will first do is to multiply the numerators together and also to multiply the denominators together. Following from there, we will achieve 48xy squared z over 12x squared yz squared. To complete the question of simplifying, we will next simplify by cancelling the common factors found in both the numerator and the denominator. So what this means is that to do the cancellation between 48 and 12, Please let me erase this highlighting first. So between 48 and 12, okay, we can find that there is a common factor of 12 between both numbers, so we will arrive at 4 over 1. Okay, so in simplifying a fraction, 48 over 12, we achieve 4 over 1. Then between x and x squared, okay, we will actually cancel away a single x and we are left with a single x at the bottom. Whereas for y squared and y, we will cancel away one single y, so we will be left with a single y in the numerator. Between z and z squared, we will also cancel away a single z, okay, such that we are left with z in the denominator. Hence, we will be getting the answer 4y over xz. We need not put a 1 in the front because by convention, we typically do not write the 1s. So this would be the answer for question 4a. Now we will take a look at part B, where we would like to divide two fractions together. So in this question, what we will have to first do is to take the fraction on the right and flip it first. Then the operation in the center should become a multiplication sign. This is the same thing that we would have done if they were numbers only. Next, we will multiply the numerators together and multiply the denominators together. Then we will arrive at this fraction, which is 32x cubed y squared z over 5yz. From here, we will then simplify the fraction such that between 32 and 5, there are no common factors, so we leave them alone. There is no x in the denominator, so we leave the term involving x alone. Between y squared and y, we will simplify by having a single y being cancelled out, such that we are left with a single y at the numerator. Then for z, we will also cancel it, hence the answer that we are going to get is 32x cubed y over 5. Moving on to part C, we are going to be dividing two algebraic fractions. So as per what we did in part B, we will flip the fraction on the right first. Hence, we are going to be achieving this. Now, we will see that in the numerator itself, we are getting 8x minus 12, and the other numerator that we have is x squared plus 4xy plus 4y squared. It is going to be a very tiring task to do the multiplication of these two expressions. So what we will do instead is to be able to observe that these two can be actually factorized. Hence, we need to always try to factorize when it is possible. It may not always be in the numerator that we can factorize. Do take note that sometimes in the denominators itself, the terms can also be factorized. So in this case, when we do the factorization for 8x minus 12, we will achieve 4 times 2x minus 3. This factorization process is where we extract the common factors. In the other numerator, the factorization process will be where we employ the cross method. So when doing the cross method, we will arrive at x plus 2y brackets square. As a recap for this cross method, I will be performing it on the left over here with the green ink. So for x squared plus 4xy plus 4y squared, we first arrange it into our multiplication frame, our cross method frame, such that we get x squared plus 4y squared plus 4xy. Now we need to think about what and what will multiply together to give me x squared. So x times x will give me x squared. So we recall that in this portion, we are going to be multiplying within the column. Okay. So then for 4y squared, we think about what could actually multiply together to achieve 4y squared. I hope that it is intuitive that you will think of 2y and 2y first. Okay, but it doesn't matter if you did not think that way, you can do a trial and error. So 2y times 2y will give me a 4y square. I am temporarily ignoring this plus sign first. Okay, so let me just put it there first. Then we do our cross multiplication, and in this column over here, we will be doing addition. So when we do a cross multiplication, x times 2y will give me 2xy. X times 2y over here will also give me 2xy. When we do the addition, if this is positive and this is positive, 2xy and 2xy will give me a positive 4xy. So since this section, this column over here is correct, what this means is that the plus sign should have actually come from inside over here. So to be consistent with the multiplication, plus and plus does give me a plus. So therefore, the answer for this will actually be x plus 2y multiplied by x plus 2y. But we also know that with x plus 2y times x plus 2y, it will be the same as writing x plus 2y bracket square, which is a simpler form. Okay, so that's how I got x plus 2y bracket square over here. Now that I have done the factorization process, I will multiply the numerators together and multiply the denominators together. So I achieve this fraction over here. Then I will now do the cancellation of common factors. So the 4 can be cancelled out because they are common factors. Then 2x minus 3 in the numerator cannot be cancelled out at the bottom. Do take note that 2x minus 3 is together on its own because of the brackets. We also see that x plus 2y bracket square is together. So it can be cancelled out with the x plus 2y with the brackets at the denominator. So I will only be able to cancel away one single x plus 2y. Therefore, the answer that we will arrive at the end will be 2x minus 3 multiplied by x plus 2y. You may now pause the video and turn to your workbook exercise 7a, page 82 to 83 to practice question 4 and question 5. The work solutions and explanations can be found in a separate video. We will now take a look at the last example that we will be covering today, which is example 5. This question is a problem sum, but don't worry, we will break it down together. This question says that there is a sum of money being divided between Shane and Vanessa in the ratio of 8:7. So this is an important part of the question. Then Shane gave $25 to Vanessa, and this ratio became 17:15. The aim of the question is to find out the amount of money Vanessa had initially. So what we need to first understand is that 8:7 is the initial ratio, and 17:15 is the ratio for now. For ratios, we can also express it as fraction. That is a very important concept and rather interchangeably used. So what we will first do to introduce algebra into the question such that we can solve things easily, we will let the initial amount that Shane and Vanessa had be $8x and $7x. So Shane has $8x, Vanessa $7x, and that is because of the ratio 8:7. Let me change this color to blue first. Okay, so that 8x:7x will still end up giving me the ratio 8:7. That is how I get this algebra out. Then, because the question says that Shane gave $25 to Vanessa, what we will then arrive at is Shane has now 8x minus $25. And then for Vanessa, she will have 7x plus $25 because Shane has given that money to her. Now, We also realize that the question specifies that the ratio has become 17:15. So the ratio of 8x minus 25 and 7x plus 25 should be equals to 17:15. Earlier on, I said that ratios are interchangeable with fractions. Hence, we arrive at this equation, which is 8x minus 25 over 7x plus 25. It will be equals to 17/15. Because these two ratios are equal, the fractions will be equal as well. Then, we will do a cross multiplication solving, which we have earlier learned about it, such that we get 15 times 8x minus 25 equals to 17 times 7x plus 25. We will then do the rainbow method or the distributive law and expand it such that we get 120x minus 375 equals to 119x plus 425. Then, moving the terms around, we will hence get the answer x equals to 800. However, do not forget that the question actually wanted us to find the amount of money that Vanessa had initially. It is not asking us to find the value of x, so be very careful over here. Hence, to find the amount that Vanessa has initially, it will actually be 7x dollars, which is 7 times 800, hence we get $5,600. Pardon me for my grammar, it should be had over here. I hope you understand how to solve this question. You may now pause the video and practice in your workbook, exercise 7a, page 83, question 6. The work solutions and its explanations can be found in a separate video. Please complete these homework questions found from your textbook exercise 7a, and the deadline is going to be on 15 June, Monday during lesson time. Please complete the questions on foolscap paper.